This job aid was produced by the National Weather Service Training Center to assist qualified NWS, DoD, and FAA electronics technicians in performing routine maintenance. This presentation will reference maintenance procedures from the relevant engineering handbook that was in use at the time of its production. The technician will refer to the most recent engineering handbook for current procedures, cautions, and warnings. Measurements captured in this video are from a non-operational site and should not be used for comparison to measurements at a field site.
RF bracketing adjustment. In this alignment, we're going to adjust the timing relationship between turning on the klystron vacuum tube and dropping the RF energy into the tube. This procedure should be performed anytime you're replacing components in the modulator, 3A15, or replacing the pulse shaper. For that matter, anything that relates to the timing of the transmitter would be a consideration. In a perfect world, we would turn the tube on 100%. We would drop our perfectly shaped waveform into the tube and get a perfectly shaped waveform out of the tube. In reality, it takes time for things to happen. We have propagation delays, we have capacitance, we have inductance. We're not going to have a perfect waveform. This procedure compensates for variables in our components. In this image here, we're showing you the turn-on voltage applied to the tube, the turn-on current applied to the tube, the energy going into the tube, and the energy coming out of the tube. Naturally not to scale. In previous versions of this procedure, we would monitor our turn-on current and our output pulse and adjust for a symmetrical output pulse that generated the most output power. In the current procedure, we only monitor the output power. Our initial conditions are to gain control of the system from the operators and put the system in standby via paragraph 3.4.1.2, steps 1 and 2. Calibrate a power meter per paragraph 3.4.4. That should be a medium power head. HP 8481 alpha as we're writing this, and the training center should have a video on calibrating power sensors up on our web page. Once we have our power meter calibrated and adjusted for our site frequency, we're going to connect it to the side of the receiver cabinet 4J25. This is the most convenient place to get a sample of our output pulse. We're going to go to System Test Software and go to the Calibration drop-down and select IFD Configuration. In the Mod Discharge block of the IFD Configuration window, you see the settings for the discharge or turning on of the vacuum tube relative to the RF being applied to the input of the vacuum tube. Give your average reading power meter time to stabilize. It's not an instant reading meter, and we're running a vacuum tube that takes a little bit of time to stabilize. Once it's stabilized, we're going to get our starting point noted. In step 2, we're going to write down what our power meter is reading, the output at 4J25, and what our initial short pulse mod discharge timing is. At this time, we're going to determine if we have our timing set to give us the peak output power. Since we've got a starting point, we're going to change our mod discharge timing by 1/10 of a microsecond and click Set Short Pulse. Your power meter should change, and we're going to write that down. If the power meter goes up when we made that 1/10 of a microsecond change, we're going to continue doing that until the power drops off. If the power decreased, in step 3 we would decrease the mod discharge timing from the original by 1/10 of a microsecond and click Set Short Pulse. We're trying to find out where the power drops off. Using this methodology, after power starts to decrease, we're going to reverse the timing setting in smaller increments until we determine where the peak power at 4J25 is found. And they provided us a table to make notes. Once you determine where the peak is, in step 6 we're going to set the short pulse timing to whatever value gave us the maximum power output. If the peak appears to be a plateau, you'd want to make a note where the power is dropping off on the leading and trailing edge or advancing and decreasing numbers, and then set your short pulse to the center of those 2 points where the power drops off. Once we've done that, we're going to click on the short pulse button to toggle it. That'll switch us over to long pulse. You'll hear your transmitter PFN switch, and we're going to do the same thing again. We're going to wait till our power meter stabilizes. We're going to measure our initial power reading at 4J25 and note the long pulse mod discharge timing. we're working with a 4.5 microsecond pulse versus a 1.5 microsecond pulse. We're going to start out by changing the timing by 0.2 of a microsecond at the time. So we'll increase the mod discharge by 0.2 and note the power change. If the power increased, we'd continue increasing by 0.2 until we see it decrease. If it decreased, continue decreasing the mod discharge timing by 0.2 until you see the power start to decrease. Make a note of this, and after the power starts to decrease, we're going to reverse the timing in smaller increments until the peak power is found at 4J25. If you find a nice marked peak, that's what we're going to set the long pulse timing to. If the power appears to be a plateau, note your points that your timing is dropping off on the upper and lower numbers and set your timing to the mid-range. Once that's done, we'll record those values and close the window. The transmitter will stop firing and we can remove our power sensor from 4J25. Anytime we've affected the output pulse of the transmitter, we need to run the IFDR alignment procedure. If you're not doing a transmitter alignment, at this point you need to do the IFD alignment procedure found in the 6-513, section 6.5. If you're doing the RF bracketing as part of a transmitter tuning, you'll perform the IFDR alignment procedure after you've completed the tuning on the klystron. At this point, we're going to exit the system test software, close, file, exit, yes, okay, click on all the pop-ups. And if you were doing this as a standalone, you would probably want to make a backup of any changes you've made to the software. But if you're going to be doing a transmitter alignment, you're going to be making a whole lot more changes, so you might as well wait till later to make that backup. If you're not doing a transmitter alignment, you would return the system to remote control by performing paragraph 3.4.1.5, steps 3 through 4. If you're doing this as part of a transmitter alignment, you're going to maintain control at the RDA. And that's it.